Hello and welcome to the Vivit SIG Talk, Big Data, Machine Learning, and Artificial Intelligence. My name is Todd DeCapua, and it is December 2017. Wanted to spend a little bit of time first helping you understand what Vivit Worldwide and the Vivit SIG Talks are. Vivit Worldwide being a non-profit organization operating independently for software users and professionals and beyond, with the intent to be able to educate, be able to advocate, and also to build a community for software professionals and beyond. The Vivit SIG Talk series is something that we've put together. There's going to be 12 months of these through all of 2018. They will be the second Tuesday of the month at 12 noon Eastern. Every session will have between 3 and 5 talks, and each of these talks lasting only 12 to 15 minutes each. As you can see, there's a schedule here on the upper right corner of this slide where you can see the schedule for all of 2018. You can also sign up for each of these. You can see this one here in December being Discover the New Tour, kind of an introduction to what it is, and then us sharing a few ideas. What you'll see then throughout the rest of the year, we'll be alternating between proven practices, testing tools, as well as tips and tricks. So each of these sessions being delivered by practitioners, all focused on quality and testing. So this will be things like functional testing, performance engineering, and security, all pertaining to the testing profession and how people are in the real world leveraging these capabilities. This will also include some live demos and a number of experts from around the industry that I'm sure you're familiar with. I would encourage you to participate as a speaker for one of these talks. There's a number of benefits as to why that would be. And you can see here at the bottom, I'm asking this question, do you have a talk yet? If you go ahead and follow the link at the bottom, it'll be a very short survey. I would encourage you to enroll in an opportunity to speak. So I will proceed with kind of kicking off with an agenda for big data, machine learning, and artificial intelligence. I'm going to speak to maybe how this relates to performance engineering a bit, but you can see from the beginning, I'm pretty sick of the hype. So we'll talk about that. Also then we'll get into a little bit on big data, machine learning, and artificial intelligence by taking a closer look in 3 different ways. One is an introduction, the second being a deep dive, third, what does the future look like and what are some of the how-tos that I've learned along the way. I will tell you there might be some bonus content in there as well. I want to talk a little bit about some summary points and next steps as we move forward in this together. You can see my little icon here on the bottom right corner of the slide. Again, being sick of the hype. So I hear a lot from many different people and individuals about big data, about machine learning, and about artificial intelligence. There's some of this in the industry that have been doing this for well over 20 or 25 years and have a number of stories to tell and how we've been able to not only help business but help customers be able to make some more informed decisions by leveraging big data, machine learning, and artificial intelligence. So with that, again, I'm sick of the hype. Let's go ahead and get some stuff done and we can proceed. We'll be starting off just with a quick introduction. You can see across the top, and if you do download the PDF version of this presentation, all of the links to each one of the definitions, all of the icons and images that I've used in the slides also will link you to exactly where I've gotten them, so that you can see that and that I am also citing all the references. I think there's a lot of confusion around what is big data, what is machine learning, and what is artificial intelligence. So I just wanted to quickly put those elementary definitions up for you, kind of briefly touch on them. Big data, you can see it's data held in such large amounts that it can be difficult to process. But again, I know that this is often a question that I will get is, Todd, do I have enough data to be able to consider this big data? Second, we'll talk a little bit about what is the definition of machine learning. So an application of artificial intelligence providing these systems to be able to automatically learn, improve, and experience without being explicitly programmed. This is focusing on the development of computer programs being able to access data and use it to learn for themselves. So again, as we think about that elementary definition, enabling machines to learn and enabling them to consume the data. So there is some programming or development needed to create these programs to be able to learn. But most importantly, it's accessing a huge amount of data or big data so that they can go through and learn. There is some also human intervention as we would look at what some of these calculations, some of these algorithms would be that we would use, and to help guide and direct that. But again, the machine learning aspect is enabling computer programs to access the data, using it then to learn for themselves. The third definition on the page, up the right hand corner, is a definition of artificial intelligence. Again, a branch of computer science dealing with the simulation of intelligent behavior in computers, or the capability of a machine to imitate intelligent human behavior. So if you've seen or heard Sophia, this is a very good example from a robotics perspective on how artificial intelligence can come to life. There are also a number of other non-UI scenarios where we've seen artificial intelligence be able to assist organizations. With the diagram that you see in front of you, this is one that I've often used to help people understand, how does all this fit together? You can see in the bottom left corner, artificial intelligence, in the bottom right corner, big data. Kind of in the middle is where this machine learning and data mining, the learning capabilities, some of these neural networks. Again, this is how all of these components play together and where they fit into the bigger picture. So again, a very good, I hope, introduction to what is big data, what is machine learning, and what is artificial intelligence. As we kind of take a deep dive into a little bit more about these three topics, and I reflect on some of the fairly significant projects that I've been fortunate enough to participate in over the years, there's these 6 points that I often come back to. Do we know all of the data points? Often you will not. So again, as you think about big data, as you think about the data that you want to make available for machine learning, as you think about the computations, the decisions, everything else that you want the artificial intelligence to be able to come up with specific answers on, do we know all of those data points? Oftentimes the answer is, well, we think so. But once you get started, you'll learn that you need something more. The second point, have all the algorithms been defined? So again, this is something that as you begin thinking about each of those three components, as you think about the data points, what do those algorithms look like? Often I'll start on a whiteboard and think through, okay, what is it that I need them to do? What are the decision points, and what are the outcomes or results that I need to think about for an algorithm or algorithms as it would relate to these three primary components. Number three, where are all the processing engines? So again, where do they live? Are they centralized? Are they decentralized? Do we know where all of them are? As you think about things like IoT or the Internet of Things, again, are they out on the fringe or on the edge of everything? Or again, are they somewhere in the middle? So again, let's think about, where do we want the processing engines and where are they today? Number 4, are there unique protocols? So as we think behind the technology, what are the protocols that we're going to be using to transmit this data? What are those components, and where are they going to be picking up the different data points that we want to capture and start including into that big data set? Because again, oftentimes you need to go out and capture and collect those data points and bring them in. What are the volumes or sizes of the data that we're going to be working with? Again, how do we want to pull that across different networks? Where do we want to store it? What are we forecasting as far as the growth rates on this data? Thinking about other things like data privacy, data protection. How is it that we're considering all of those elements as well? How do we create, reset, and refresh? This is thinking through the data. This is thinking through not only development, also production deployment, and again, how is it that our production environment will be living as we create, reset, and refresh all of the different data sets. As we move into the future and the how-tos, there was a reference that I wanted to call out, which was from Forrester. Forrester being one of the larger analyst firms in the world, and I believe one of the more respected analyst firms in the world. They have a paper out, and you can see it's forrester.com/predictions. You can get access to the same report that I pulled some of this data from by simply going there. Some of the results that you'll see is 75% of early artificial intelligence projects will underwhelm due to operational oversights. So again, if you follow the 6 points that we just spoke through, this will help you to reduce that underwhelm effect. Again, a couple more links here. Predictions for 2018, a year of reckoning, that coming from Forrester. And again, you can see another link there at the bottom so that you can get access to that data. Following on the 6 points on the prior, diving a little deeper, now thinking about some of the how-tos. How are you defining the objectives? What are the objectives of you going through and capturing your big data, applying machine learning, enabling artificial intelligence on the tail end of it, or maybe throughout? But what are the objectives that you have from a business perspective? Let's think about that early, and let's think about that often. How can we break this down into subcycles? Again, we're not going to know everything. We are going to learn, and we're going to want to incorporate that learning as we go. Number 3, mapping the flow and the scenarios. I'd suggested a whiteboard. I've often used white pieces of paper. You could do it electronically, but I often find a fairly mini short workshop of maybe a few hours to be able to map out the flow and map out the various scenarios with the right informed individuals in the room is often extremely helpful. How do you create the environment? Again, what is that development environment? What is that, testing environment? What is all your pre-prod environments? What does that look like? What does your production environment look like? How can you create that? Data becomes a huge challenge. But again, let's think about it early. How are we going to create the data? Where are we going to store it? What are the data privacy considerations that we need to make as well? Validating the algorithms. So this is a critical element that as you are continuing to develop and test, again, validating that your algorithm or algorithms are indeed performing and providing you all the right logic and the outcomes that you are desiring. You want to validate the data and validate the feeds. In some of these projects that I've had the opportunity to work in, oftentimes many of the data feeds that we received were third-party externals. So again, we needed to validate that as it was coming in before we went ahead and made it a part of the larger big data set. So not to have any other challenges. Again, this data can change in format, it can change in structure. Very important to ensure that not only at the beginning but also ongoing that you're validating that data, validating those feeds. And then review the results. Make sure that you are getting what you're expecting. If it is not, again, as you think about the way machine learning works, it's going to learn, it's going to apply, but you need to review the results and continually ensure that, again, that machine learning is applied the way that you intend on it, and at the end of it, when the artificial intelligence comes to light, that you are getting the results that you indeed are desiring. So I also wanted to highlight just some quick bonus content. I think there's a good blog that I picked up on a little bit more, thinking about, how is it that from a tools perspective, some organizations are attacking this artificial intelligence opportunity. So again, highlighting here a blog from Dynatrace, auto mitigation with Dynatrace AI, or shall we call it self-healing. So again, leveraging all of the data that this organization, Dynatrace, is able to capture, and then you can see how they've applied logic to that to enable, potentially, has that impact been mitigated, yes or no? Is it still ongoing? Should we initiate a rollback? If it is still ongoing, then do we need to notify through escalation? But again, this is just an example of how one tool organization is proposing that they could help you to improve your mean time to resolution through automated mitigation with artificial intelligence and the data that's captured behind the scenes. So wanted to highlight that for you quickly. Again, my name is Todd DeCapua. I would like to thank you for listening to this Vivit SIG talk. If you would like to continue the conversation, @perfeng is my Twitter handle, and would gladly connect with you and continue the dialogue there. Thanks again for your time. Bye-bye.